Hi, junior superheroes. To convey the importance of rounding, I'm going to turn to the amazing Richard Pryor in the otherwise not so great sequel to Superman. In this wonderful movie, Pryor plays this computer genius who works for this evil multinational huge conglomerate, and after he gets his first paycheck and is bewildered by all of the taxes and everything taken out, he also finds out that this huge company has millions of dollars that it has in rounded cents, in rounded pennies that get rounded down. And, well, see for yourself what he does about it.
Hey, what is this?
First paycheck?
It's the first ripoff, man. It's supposed to get $2.25 a week, right? This says $143.80. How am I supposed to live on that? Oh, yeah. State tax, federal tax, Social Security tax.
All right, so you're still getting some money when you hit 65.
So I'm getting money when I hit 65? I want mine now. Well, I can enjoy while I'm young. I want to get out there and get down. Boogie. Boogie, boogie.
Actually, it's probably more like $143.80 and 1/2 cents. There are always fractions left over in big corporations, but they round it down to the lowest whole number.
What am I supposed to do with 1/2 cent? Buy a third red mouse? You mean everybody loses those fractions?
Well, they don't exactly lose them. You can't lose what you never got.
Then what happens to all those 1/2 cents? The company gets it?
No, not really. They can't be bothered to collect a 1/2 cent from your paycheck any more than you could.
Then what happens to them?
Well, they're just floating around out there. The computer's nowhere. How many sugars?
1.5.
It's quitting time, Gus. You coming?
Yeah. No, actually, I got some stuff to finish up, so.
Working overtime, huh? What you doing, buddy? Looking for a raise?
Yeah, looking for a raise.
That's it. You bet.
Okay, great. Now what's missing in there, what I can't find on YouTube, is a video clip of his reaction when he gets his first paycheck after converting all of that, all of those missing 1/2 cents into his own account. That's part of the movie. Okay, let's continue. So yes, today I want to talk about what I call significant figures and some rounding rules. All right, now what do I mean by significant figures? Some people call these decimal places. All right, so when it comes time to round numbers, how many decimal places should we be rounding to? So here's some general rules that I have about significant figures, and then some additional rules about rounding. So our general rule of thumb is we're going to round things generally to 2 significant figures, or in other words, 2 decimal places, 2 decimal places of precision. So when all else fails, you're going to see that this is what we turn to more often than not. All right, so that's our rule of thumb. When in doubt, round to 2 decimal places. But more specifically, I want you to get in the habit of rounding final answers to 2 decimal places beyond the raw. What do I mean here? First of all, what do I mean by final answers? So when you're doing a calculation that requires some cerebration, or a calculator or the computer is rounded for you, and you're calculating something like a mean or a standard deviation, something that's considered to be a final answer. All right, a final computation. Sometimes, as you'll see, there's going to be intermediate steps. There's going to be steps in we're filling out, we're computing formulas, and we'll have to pause and we'll have to calculate something along the way. I'll call those intermediate steps, and I've got something to say about those in a moment. Okay, so when we get to the final answer, I want you to round to 2 decimal places beyond the raw. By beyond the raw, I mean beyond whatever the raw data is that you're starting with. If the numbers were whole digits, whole numbers, whole numbers, then we'll go with that original rule of thumb. We'll round to 2 decimal places, all right? However, if the numbers that we started with had 1 decimal place, so there were numbers like 1.3, 4.6, and so on, all right? So if we started with 1 decimal place of precision already, we should take our final answer to 2 places beyond that. So that should go out to 3 decimal places. And likewise, if we had 2-digit numbers to start with, 2.36, 1.48, okay, numbers that have 2 decimal places of precision, then our final answers will be rounded out to 4 decimal places, 2 beyond what we started with. Okay? So you dig? 2 decimal places beyond the raw for final answers, okay? And we do that because we like to be precise. We like to be superheroes. That's what Batman would do, all right? Be precise. I'm going to tell you that. That's going to be my plea all term, all right? Be precise. And we work hard for it. You've done, when you're doing calculations that require calculators and computers, or a lot of thought on your part, okay? You worked hard for that precision. Hold on to it. Don't throw it away so readily. Don't round intermediate steps if you're using a calculator or if it's not terribly convenient, okay? So now time for those intermediate steps. So when you're doing some other formula, some bigger formula perhaps, that has, that requires you to calculate something, along the way, and maybe you're doing some division and now you have a calculator display full of, all kinds of precise numbers, all right? So one option is to not round at all. Just use that precise number carried over into the next part of the calculation, okay? So that's one option. You never can go wrong being, I'll never tell you that you're being too precise, okay? It's much more likely that I'll criticize you for lacking precision, okay? So I can always round numbers away if you have too many of them, but if you've rounded too many of them, and then I can't see your work anymore. Okay, so don't round if it's terribly inconvenient, but sometimes it just is terribly inconvenient. So for intermediate steps, then I want you to carry your rounding out to at least 4 decimal places beyond the raw data. Okay, so if your numbers were whole numbers, take these intermediate steps not just to 2 decimal places, but go out to 4. Okay, and then when you get to your final answer, you can round it to 2. On the other hand, if you had 4 decimal place numbers that you were starting with, and that's not going to happen to us probably very often, if ever, in this class, but if you have 4 decimal places of precision, so numbers like 1.2367, okay, and starting numbers like that, okay, well then you're going to have to take those intermediate steps to 4 decimal places beyond that. So you should take your answer, you take those intermediate step answers out to 8 decimal places of precision, so that when you're all done, you can round the final answer to 6 decimal places of precision, okay? See, this gets complicated. All right, so intermediate steps to at least 4 places beyond what you started with as raw data. Okay, so now let's talk about rounding. I bet you all think you know how to round. I'm about to turn your world upside down and show you that chances are really great that you've been wrong. I have yet to meet a student that has ever rounded correctly. Not a 1. Maybe you'll be the first. So, what are we going to do what do we do with the final digit or digits to be rounded, okay? So what did you all learn, all right? So if the final digit, let's say you have 3 decimal places and you want to round to 2, okay? So what about that final digit that you want to round away? Okay, what did you all learn? If the answer is less than 5, round it down, right? So if you have a number like 4.134 here, all right, and you want to round that to 2 decimal places, you drop the 4, right, and round it down to 4.13, all right? No brainer. If it's less than 5, round down, right? What do you do if it's greater than 5? Round up, right? So a number like 4.136, to round that up to 2 decimal places, we'll round it to up to 4.14, okay? So nothing new, nothing different there. Well, what about if it's exactly 5? If it's less than 5, go down. If it's greater than 5, go up. What did you all learn to do if it's 5? 5 or greater, round it up, right? That's what you all learned. 5 or greater, round it up. You didn't have this rule greater than 5. It was 5 or greater, you would round it up, okay? Well, I'm about to turn your world aside, okay? So our new rule is going to be if it's exactly a 5, so we're talking about a relatively rare occurrence here when it's a smack dab 5 is the last number that we want to round away. Anything greater than that is greater than 5 and will go up. No controversy there. But what if it's a smack dab 5 is the last number that you want to toss out, okay? You all learned to round it up. 5 or greater goes up. My new rule is going to be we'll round it up or down so that the final answer is even. In other words, round it up or down to the nearest even number. What? Why on earth would we do that? Well, consider the possibilities of remainders. So here they are, all right? So the possible remainders that you could have is that final digit to toss away is a 1, 2, 3, 4, 5, 6, 7, 8, or a 9. I'm not including 0 because 0 is 0, and 0 wouldn't be rounded. 0 is 0, okay? So you have 9 options for remainders. And so what did you all learn to do? You all learned to round 5 or up, 5 or greater, up. So look what you were doing here. Look what you were doing here. You were biased. Only 4 times out of 9 would you be rounding down. 5 times out of 9, however, you were rounding up. You were biased to round up. So unlike Richard Pryor's company, they were just kind of rounding down to the nearest cent all the time, no matter what the remainder was, and there were all these missing cents that he was able to capture and pile up into his own bank account. Okay, so kind of similar. All right. So anyway, the corporation was biased to round down. In fact, they were rounding all 9 digits down, but that's another matter. Okay, so back to this crazy rule. Why am I doing this? I'm doing this so that to prevent a bias. Okay, we've talked previously about how we don't like systematic biases. If you were doing this, you were systematically biasing yourself to round things up. 5 times you're rounding up, only 4 times are you rounding down. Okay, so we need a rule to balance things out here. So what to do again with that smack dab 5? Well, there's lots of options so that half the time we go up and half the time we go down. Okay, you could just randomly decide, this time I'm going up, this time I'm going down. Well, maybe you'd be biased one way or another. Plus, in a classroom, if we were in a classroom, or even when we're not, I want you all to be getting the same answers that I'm getting, okay? So if half of you are rounding down and half of you are rounding up, yeah, sometimes we're all going to be getting different answers. So we need a systematic rule. Well, my rule then, again, is we'll round up or down so that the nearest number is going to be even. So the final answer is an even number. Round up or down to the nearest even. I could have said round up or down to the nearest odd. So I just chose even. Okay, so we're all doing this. So let me catch up with myself here. So let's try a couple of examples here. Okay, so let's consider this number, 3.665. I want to round that to 2 decimal places, say. So I've got this 5 as a nice as an only remainder here. All right. You all learn to just round that up, but following my rule, you would round that down because the nearest even number is down to 3.66. Okay. You would have rounded it to 3.67 using your good old-fashioned rule. Okay. You'd be biased to take it up. Okay. Now, some students often ask me, why not round it up to 3.868? Well, that's not the nearest even number. Do you see how 3.66 is closer than 3.68? If you round it up to 8, you'd be overly rounding. Okay. So let's try another one. 3.675. Okay. Want to get rid of that remainder of 5. Okay. You all learn to take that up to 3.68, and so you'd be correct. So the good news is that even with my new rule, half the time, if you forget it, half the time you're going to get it right anyway, okay? So half the time we're going to do just what you always learn to do. We'd round it up because the nearest even number here is 3.68, rounded up to 3.68. All right, how about this one, 3.685? What does that round to? Pause and think about that. Okay, what will 3.685 round up to? Okay, I don't have the answer to show you, but the nearest even is down again, so 3.68 would be the answer for this one. Okay, I find that some students get a little confused here, so let's try a couple more just for practice, all right? So let's round these to 2 significant figures. So same pattern that we've been doing here. We have 3 remainders here, and I want to get rid of 1, so I have 2 remainders. So 7.235, I want to get rid of the 5 here. What does that become? You all learned to take that to 7.24. Is that correct here? Yes, it is. Okay, again, half the time you're going to be doing the right thing anyway. So we'll take this up to the nearest even, which is 24. Okay, 7.24. Nothing new and different there. All right, consider this one, 7.245. What does that become? If you said 7.24 again, good, correct. So this time the nearest even is down to 24. All right, so both of those numbers, using my rule, would round down, up or down, to they would both result in 7.24. All right, now your good old-fashioned way of doing it would have been biased, and you would have taken that up to 7.25, wouldn't you? Okay, so you would have been biased to always go up. Okay, let's try slightly different examples. Okay, so round these to 3 significant figures here. So I've got 4 decimals here that I want to round to 3. So 10.0005 becomes what? So this one's a little tricky for 2 reasons. Now we're doing 3 digits instead of 2. And we also have a 0 in there. So what's 0? Is 0 odd or even? Well, 0 is considered to be an even number, even though it's, okay, it says 0 is considered to be an even number. So in this case, we should round it down to the nearest even. So we have 3 decimal places of precision here, 10.000. Okay, this is a good place to, this reminds me that I got to tell you about something else that's drop dead important to me. All right, so we started this conversation by saying, you know, final answers should be rounded to at least 2 decimal places of precision, 2 decimal places beyond the raw. Okay. So in this case, I wanted to round to 3 significant figures here. So the answer is 10.000. You might have been tempted to just write 10. Now, what's the difference between 10 and 10.000? I argue that those are not the same number. All right, 10 versus 10.000. They're not the same number to me. 10.000 tells me, you have rounded to at least 3 decimal places of precision. This answer I'm looking at is precise to the 1000th place, okay? Conversely, if you just tell me 10, I'm left wondering, what has that been rounded from, all right? Okay, so to me, there's a big difference between 10 and 10.00 or 10.000. Okay, let's move on. How about this one? 10.0015. Again, I want to round this to 3 decimal places. What does that become? You all learned to take that up. You would have all rounded that to 10.002. Is that correct today? Yes. So again, half the time we're going to be doing what you learned to do anyway, okay? So up or down to the nearest even. So up to the nearest even is 002. All right, last one. I have now 5 decimal places. I want to round to 3 decimal places of precision. So 10.00251. What do I do here? What do I do here? Okay, this one's kind of a trick one. This one's trick question. So should I go up or down to the nearest even? The rule doesn't apply. My remainder is no longer just a 5. It's a 5-1. 5-1's greater than 5. Say that again. Okay. I want to round this to 3 decimal places, and so this one's going to go up, and it has nothing to do with my up or down rule, okay? So that's 5-1 is greater than 5, so that one goes up, okay? 10.003, all right. Okay, so there's a handful of new rules for you, okay? Significant figures. We're gonna take final answers to at least 2 decimal places beyond what we started with. We're generally, but not always, but generally going to be using whole numbers in this class. So the rule of thumb of showing final answers to 2 decimal places will largely serve you well. But Be precise. When I have 3 or more decimal places, then you're going to be taking your final answers to at least 2 beyond what you started with. Okay? Intermediate steps when you have them, when you're calculating, and you have intermediate steps. These aren't final answers, but steps that you're working into the rest of the equation. Okay? You're going to want to take those to 4 places beyond what you started with. Okay? And then we had the rounding rules. Okay? So a slight new twist on your rounding rules, and then my conversation about the importance and the difference between a number like 10 and 10.00. On an exam, if the answer is supposed to be 10.00 and you just put 10, you're going to get a little deduction. All right? On the second and third exams, the deduction is going to be even greater. By then, I expect you to know this very well. Okay? So don't get deductions. Be precise. You're working hard for your superhero status. Don't throw it away. It's better to be more precise than too imprecise. What would Batman do? See you next time.